Hey class, it's Mr. M again, looking here at an assessment question dealing with absolute extrema and finding their locations. Remember, you'll always be given an interval over which to find absolute extremes, and in this case we're only concerned with how this function is behaving in this particular window from -1 to 2. And keep that in mind, because if we find some interesting values outside of that interval, those are great, but they're not really what we're concerned about at the moment. So recall that absolute extrema occur only at either endpoints or critical numbers in the interval. So we'll have to consider both. So those -1 and that -2 we'll come back to in just a moment. Let's go ahead and do a little bit of calculus and find the critical numbers. So take the derivative whenever you're in doubt. And here you'll get 3x squared minus 8x. And to find a critical number, set it equal to 0. Here you can factor an x out, which would give you 3x minus 8 equals 0. And so we have two critical values, critical numbers. X is equal to 0 coming from here, and 3x minus 8 equals 0 implies that x is equal to 8/3, or 2 2/3, to give you an idea of where that is. So we have two critical values, and here's where it's important to recognize where we're concerned with. We're only concerned about this part of our globe, because remember, another word for absolute extremes are global extremes. -1 to 2. Does 0 fit in that interval? Indeed it does, so that's one place to investigate. But 2 2/3 does not. So there's something interesting happening there, but for the moment, since we're asked about -1 and 2, we're not too concerned about what's happening there. So no fractions to deal with. Breathe a sigh of relief. So critical numbers are potential points for absolute extremes, but so are endpoints. So let's test our endpoints. And we want to find the greatest and the least y value, which again comes from f, not from f prime, because the derivative is a slope, not a location. So f prime of -1 should give you, let's see here, -1 cubed minus 4 -1 squared plus 7. This will be negative minus 4 plus 7, which should give you 2. Likewise, f of 2, dealing with our endpoints. F of 2 is 2 cubed minus 4 times 2 squared plus 7. Plugging in 2 will give you 8 minus 16 plus 7, which is -1. So there are our endpoints. -1 produces a 2, and 2 produces a -1. So let me highlight those. Never use a real highlighter on a chalkboard, by the way. Finally, let's deal with our critical number. In this case, only one of them. That was x equals 0. So f of 0, plug it in, and you obviously get 7. So this makes our life quite easy, isn't it? No fractions. So we have the following values. We have 2, we have -1, and we have 7. Well, the smallest of those is obviously -1, so that's our absolute min. And the greatest of these is obviously 7, and that's our absolute max. So how do we state this in a reasonable way? I was hoping to fit this on the slide, but it won't fit. So keep this in mind. You can rewind if you need to. Oops. At x equals 0, f has an absolute max. Keep spelling x. Go back for a moment. And at x equals -1, excuse me, at x equals 2, f has an absolute. And there you go. To review, find critical numbers by finding the derivative and setting it equal to 0, and test it, as well as the endpoints, to find your highest and lowest output into f. The highest is your absolute max, which in this case was 7. The lowest is your absolute min, which in this case was -1. Alright, hope this helped.